Hi guys, here is a question that we need to solve, and so I read it first. Evaluate the triple integral. So guys, our triple integral is right here, and this is what we want to integrate. So the first thing guys we are going to look is the region for which we want to integrate. And so guys, I can write here, I can remove this one, and then I use this. So I will write E. This is now we are looking for the region we are supposed to integrate. E. This region is given by the Cartesian plane, which is represented by X, Y, and Z, like that. So we draw a stroke there now so that we can now come to our region. The first region is between 2 and -2 and 2. So this one we write -2 less or equal to, our region is X, supposed to be X, that is now between -2 and 2, written like that. Coming to this other dy, shall have -4, negative square root 4 minus x squared. This one now guys is the region of y. We write it like that. So this other one will be 4 minus x squared. So guys, finally we come to the region of z. This one is represented by x squared plus y squared, like that. And guys, for this is actually the height, represent the height of a cone. And so it's like that. This is z, and here we have now the height of the cone. The upper limit is 2. So guys, because of this, we know that this is supposed to be a cone. And so guys, this is our diagram right here of a cone. As we have said, you can see the height of the cone is 2. And this equation now represents the cone. That is, along the y, the z axis, our height is going to be given by that. Then we have the limits. For the y, we have that. We also have the upper limit. For the x, we have the lower limit, that is the upper limit. So using this cone, guys, we are going to come up with a region in polar form. In the polar form, guys, we are going to write here E. E is going to be equal to, in polar form, guys, this one we write as R, we write theta there, and Z, that is in polar form. So can write a stroke there, and guys, we now come and check here. We can see along the Z axis, guys, we are coming from this point along that slanted height, that is x squared. So we are going to integrate between square root of x squared plus square root of x squared plus y squared, which guys in polar form, this one we get is r, like that. It's supposed to be r for this, that is r, and then up to, so we can write that, that is z. Z is between r and now 2. This is 2. Then we go now, after we integrate that up to that point, guys, we can integrate along the radius. Along the radius, that is 0. this one is now the radius, and our radius, maximum radius for this is supposed to be 2, as you can see here. Supposed to be 2 for this circle, and so I write 2 there. Then guys, I now go to theta. For theta, guys, we are going to rotate. After we have moved from this point to this point, we rotate the whole of that sector or element around that, which is now 2 pi. So this one will be from 0 to now 2 pi. So that's how we are going to do that question. And so guys, we can now write our integral. That is, we can start with any, we can come here and write integral like that from, this is r to 2. Remember this one is for dz, so we can write dz there. That is dz. And before we continue, we have this here. We have, for us, we also have here in the center, we have this. And this one, guys, we are saying is supposed to be represented by r squared. X squared plus y squared is r, is our radius. So we have to write that. We go back again now to what we have here, guys. We have dealt with, that is this one first. And so guys, we come to the second integral. For the second integral, guys, we can choose the r. So if we choose r, and before that, guys, we can come and convert this. Dy dx is given by d, is given by r. D theta, we start with the dr, then d theta, like that. So that now, guys, when I come here, I will choose this. So with respect to dr, we shall have 0 to 2. With respect to d theta, we shall have 0 to 2 pi. So guys, we can now actually integrate right now. So this is now going to be, we start here, but before we do that, we multiply this and that. So we shall have integral of limit r to 2. We have now r cubed, and then here we write, we start with dz. So guys, for that, we are going to have r cubed, then z, limit from r to 2, like that. So this one will give us r, that is 2 r cubed. Remember that at this point r is constant because we are integrating with respect to z. That's why I wrote z there. This one is minus, this one we have r, so this r is going to be r raised to 4, like that. So guys, from there we come and now integrate once again. Now with respect to dr, so we shall have something like this. This one now will be 2r cubed minus r raised to 4, and here we have dr. For dr we have 0 to 2, 0 to 2. So this one is going to be 2 r raised to 4 all over 4, that is when we integrate r cubed, minus this is r raised to 5 all over 5, limits from 0 to 2. And so guys, we can now come and replace for 2, because when you replace for 0, it's 0. So for 2 is going to be, here is going to be 16 times 2, that is 32 all over 4, minus, still this one is going to be 32 all over 5. And so guys, we are going to find this. This one is going to give us, let's see. So this one we shall have 8 minus 32 all over 5. So it will come to like 40 all over 5. This is like 40 all over 5. 40 all over 5 minus 32 over 5. This one gives us 8 all over 5, like that. So guys, we come and now integrate. Now with respect to d theta. With respect to d theta here. So this guys, we are going to do that with respect to d theta. And here is our, this is now what we are talking about, from 0 to 2 pi. So we integrate that from 0 to 2 pi. So this is 8 over 5 d theta. So this is going to be 8 over 5 theta, like that, from 0 to 2 pi. So this one will now have 2 pi multiplied by 8. That is going to be now, if we put 2 pi here, we shall have 16 pi over 5. And so guys, this is our solution. Thank you for listening to me. Bye bye.